Hello everyone, today I'm gonna explain the significant figure rules by using several example questions. Okay, so now let's look at this. Okay, and then so the first number over here, okay, so the first number is 53 centimeter. Okay, so in this situation, both numbers we have in this measurements are non-zero numbers, so both of them are significant. So in this number we have two sig figs. Okay, we have two significant figures. Okay, both of them are significant. Okay, and then in the second number, question number B. Okay, so question B, so it's 2.05 times 10 to the power 8. Okay, remember this is a scientific notation expression. Okay, so in this expression, this 10 to the power 8. When we're trying to tell sig figs, we don't look at it. Okay, so we're only paying attention to the number over here. Okay, so the number over here is 2.05. As we explained part of the rule, if you have non-zero numbers, they're significant. So both 2 and 5 are significant. And this zero in this number, this zero, okay, so it's trapped in between. Okay, so it's trapped in between, so it's also significant. Therefore, all the numbers in this 2.05, they're all significant. So the answer for this B will be 3 sig figs. Okay, so 3 sig figs. Okay. Next number C. Okay, so you have 86,002 joules. Okay, so that means again following the same rule. So all the non-zero numbers are significant. So 8, 6, and 2, they're significant, and then these zeros trapped in between, again they're interior zeros. Okay, so they're also significant. So every number in this measurements, they're all significant. So therefore the answer for this will be 5 sig fig. Okay, 5 significant figures. Okay, now let's look at D. Okay, so if you look at D over here, okay, so again we don't look at this 10 to the power 4. That means you have 4 zeros following. Okay, but then again, the way we're expressing how the measurements are, how precise or accurate the number is, we're looking at the front part. So that this 9.740. Okay, so we're looking at this. Okay, same old rule. So if you have non-zero numbers, they're all significant. So this 974, all significant. And then you have, okay, so let's look at this zero. Look at this zero right over here. Okay, so this zero, that's what we call as a trailing zero. That's after this decimal point. Okay, so after decimal point, it matters. Okay, it is significant. Okay, so it's there to tell you, okay, up to that digit, we could measure up to that. Okay, and of course, as we talk about the last digits estimated, but anyway, so in this case, if again the rule is after decimal point, if we have a zero, that's what we call as trailing zero, which will be significant. Okay, so this is significant. Okay, so significant. Okay, so therefore in this whole expression, right, or whole measurements, 9.740, all of them are significant. Okay, so therefore you have 4 sig figs in these measurements. Okay, so 4 sig figs. Okay, so now let's look at the next example. Okay, so the next example we have is 10.0613 cubic meter. Okay, so in this number, same old rule, we're looking at the non-zero numbers. They're all significant, and then the zeros trapped in between. Doesn't matter if you have one before the decimal point, one after the decimal point, they're trapped in between, they're significant. So you count all the digits, so you have 1, 2, 3, 4, 5, 6. So all the numbers in this measurement, they're significant. So you have 6 sig figs. Okay, and then the next one will be 0.17. Okay, so we start off with the non-zero numbers. You go, okay, so let's see, you have 1 and 7, they're non-zero numbers, they're significant. And then you go, what about this zero? This zero before the decimal point, that's what we call as the leading zeros. Okay, so this leading zero over here, this is a leading zero. Okay, this leading zero will be not significant. They're just there to hold a place. Okay, so that means the measurements, you start to get real numbers you get the non-zero numbers after the decimal point. Okay, so therefore this 1 and 7, they are significant. This 0 is not. Okay, so then in this measurement you have 2 sig figs. Okay, 2 sig figs. And then the reason for that, again, think about this 0.17. You can also express it with scientific notation. So you can turn this same value into a scientific notation. That'll be 1.7 times 10 to the power negative 1. As we talked about earlier, when you have that 10 to a certain power, we don't look at it. That's not going to affect the sig figs for our measurements. We're only looking over here. Okay, so if you're using this expression, again, of course, you have 2 sig figs, right? 2 sig figs. Okay, so both expressions make sense. They come to the same conclusion because at the end of the day, that's the same measurements. You just either expressing with scientific notation or not, but how precise or accurate your measurements are should be consistent, right? 2 sig figs. Okay. Okay, so the last example is 0.88400. Okay, so if you look at this number, same old rule, you look at the non-zero numbers, 884, they're all significant. Okay, and then the situation will be, okay, you have 2 zeros over here. So those are the zeros after decimal point. Those are the zeros we call as the trailing zeros. Trailing zeros. Okay, so they are significant. They're there to indicate how many sig figs, how precise, how accurate your measurements could be. Okay, so therefore these two are significant. Okay, so significant, and then the zeros up front, the zero up front, right over here. That's what we call as the leading zero, which is not significant. Okay, so therefore in these measurements, this 88400, those are the significant figures. Okay, so I have 5 sig figs in these measurements. Thank you for listening, and then hope this is helpful.